Definite integration. It is used in physics when a given function varies over certain fixed limits of the variable. Consider this graph. Along the y-axis and x-axis we have the plot of velocity versus time, and this plot is over a to b of the given time period. So we have the limits, we have the velocity variation from a to b. To find the distance covered during this time, we need to find the area under the curve. That means this entire shaded area will give us the value of distance covered during the motion from A to B. So, area under the curve. Now for that we use definite integration denoted by integration of fx dx from A to B. Integration of fx dx will be capital F x. These limits now are written over the bracket as A to B. You have to apply them as such that f of b minus f of a. Keep in mind that unlike indefinite integration, definite integration does not have a plus constant, because when you solve the limits, the value of the constant is directly found. So you don't need to add the constant when you are using definite integration. We will now solve an example to understand application of definite integration clearly. Consider this. Integration of x square dx from 1 to 2. So here function of x is x square, a is 1 and b is 2. So first we solve fx dx. That will be equal to x cube upon 3. From a to b here we write from 1 to 2. Then we apply the upper limits and lower limits to the function. So here upper limit 2 and lower limit 1 will be applied to x cube as the function of x. So that will be 1 by 3 as it is, 2 cube minus 1 cube. That will be 1 by 3, 2 cube is 8 minus 1. So integration of x square dx from 1 to 2 will be equals to 7 upon 3. This is all you need to know to apply definite integration in physics. Practice more and more questions like this by yourself using your textbooks or other reference books, and when we apply it to physics, it will be easier for you to understand the application.